This video is Vehicle Roll Center Part 2, and it explains how to find the kinematic roll center of a vehicle using the geometry of the suspension. The roll center of a vehicle is the instantaneous center of the body relative to the ground. Watching this video will give you a clear understanding of how to find the roll center for various suspensions. In this video I'll be explaining the assumptions behind finding the kinematic roll centers, positive and negative suspension geometry, and the roll center for different suspension types. The suspension types I'll be explaining are double A-arm suspension, Macpherson suspension. Rest of suspensions will be explained in the next videos. They are pure straight slider suspension, driven swing axle suspension, low pivot swing arm suspension, trailing arm suspension, for link rear suspension, 3-link rear suspension, for link parallel lower arm suspension, and Hotchkiss rear suspension. I have a quiz for you. In what case is the kinematic roll center located in the central longitudinal plane of the vehicle? Asymmetric suspension. When a relatively large lateral forces are applied in a symmetric suspension. When the suspension is symmetrical and a relatively small lateral forces are applied. When the deformations of the suspension bushes are large. Please choose one of 4. To find the kinematic roll center, the following assumptions are required. The distance between the left and right tires is constant. The tires are assumed to be fixed to the road surface by rotatable pins. The deformations of the suspension bushes and tires are ignored. The lateral acceleration is small enough that there is little change in the suspension. Based on the above assumptions, let's find the roll centers of representative suspensions one by one. Is the roll center located in the central longitudinal plane of the vehicle? In a symmetrical suspension, if the lateral acceleration is small, the roll center is located in the central longitudinal plane of the vehicle. However, if the suspension is not symmetrical, or if the body roll angle is large due to the lateral acceleration, the roll center will be off the central longitudinal plane of the vehicle. The roll center does not necessarily have to be located in the center longitudinal plane. However, in this video, to help explain and understand how to find the roll center, let's assume a suspension that is symmetrical, has small lateral acceleration, and has the roll center located in the central longitudinal plane of the vehicle. In general, the links of a vehicle's suspension are not parallel or perpendicular to the vehicle's main axis, but have given angles. In order to find the instant center, the vehicle's suspension must be projected onto a plane which can be a top, side, or rear view. On that plane, the positions of the links and joints must be determined, and analysis must be performed based on this projected plane. Let's first learn about the related prior knowledge. These are the swing center, positive swing arm geometry, and negative swing arm geometry. In order to find the roll center, we must first find the instant center of the wheel with respect to the body. In a double A-arm suspension, the point where the upper arm and lower arm meet when extended in a straight line is the instant center of the wheel with respect to the body, and this is called the swing center. The swing center is the virtual reaction point of the force entering the link through the tire, and is called the virtual reaction point. There are 2 swing centers, one for the left wheel and one for the right wheel. The left and right pictures here show the rear views of the left suspension for 2 vehicles with different installation angles for the upper and lower arms. These swing centers can exist inside the vehicle, as shown in the left figure, or outside the vehicle, as shown in the right figure, depending on the attitude of the links. The arrangement of the suspension links where the swing center is created inside the vehicle, as shown in the left figure, is called positive swing arm geometry, and conversely, the arrangement of the suspension links where the swing center is created outside the vehicle, as shown in the right figure, is called negative swing arm geometry. Let's continue to find out why they are called this way. To find the roll center, connect the swing center of the left wheel and the road contact point of the left tire with a straight line, and also connect the swing center of the right wheel and the road contact point of the right tire with a straight line. The contact point between the tire and the road is the point where the vertical line from the wheel center meets the road. In this way, the two straight lines will meet each other on the longitudinal section of the vehicle, and this point is the roll center. In positive swing arm geometry, the swing center is inside the vehicle, so when the roll center is found by connecting it with the tire contact point and a straight line, the roll center is formed higher than the ground and roll center height has a positive value. Therefore, this arrangement of suspension links is called positive swing arm geometry. On the other hand, in negative swing arm geometry, the swing center is outside the vehicle, so when the roll center is found by connecting it with the tire contact point and a straight line, the roll center is formed lower than the ground and roll center height has a negative value. Therefore, this arrangement of suspension links is called negative swing arm geometry. First, let's find the roll center for a suspension with a positive swing arm geometry. As explained earlier, in a positive swing arm, the extensions of the third and fourth links in the figure meet inside the vehicle, and the extensions of the sixth and seventh links also meet inside the vehicle. Conversely, in a negative double A arm, these extensions meet outside the wheel. We'll look at each of these characteristics in future videos, but for now, let's focus on finding the roll center. As we saw in the previous video, the total number of links for a double A-arm suspension is 8, and the total number of joints is 10. Therefore, there are a total of 28 instant centers. Fortunately, we don't need to find all of these instant centers. The instant center we need to find are two swing centers and the instant center of the body 5 with respect to the road 1, which is the roll center we've been using. As explained in the previous video E0069, roll center part 1, the roll center is a position that is fixed at that instant and will continue to change as the lateral force increases, the body roll angle increases, the angles of the suspension links change, or the tires and bushes deform. To find the roll center, we use the Kennedy circle, which was explained in the previous video E0069. Since there are 8 links, we draw 8 points on the Kennedy circle, as shown in the left figure. What we want to find is the instant center of body 5 for road 1, so we connect this with a straight line on the Kennedy circle and mark it as I15. It is indicated with a thick blue line and blue letters in the left figure. The straight line connecting link 1 and link 5 is I15, and the triangles sharing this line on the Kennedy circle are link 158 and link 152. According to Kennedy's theorem, the instant center, I18, I58, and I15 of the left triangle must all be on a straight line. Also, the instant center, I12, I25, and I15 of the right triangle must all be on a straight line. In order to find the instant center, I15 of body 5 with respect to the road 1, we must first find the instant center I58 of the right wheel 8 with respect to body 5 and the instant center I25 of the left wheel 2 with respect to body 5. These two instant centers are the swing centers explained earlier. First, let's look at the triangle 158 of the Kennedy circle. According to Kennedy's theorem, the instantaneous centers represented by each line segment of the triangle 158 must all be on a straight line. Among the 3 instant centers, I18 is the joint connecting link 1 and link 8, so it can be easily found, as shown in the figure on the right. The lateral cross-section and longitudinal cross-section of the vehicle passing through the instant center I18 both pass through the center of the right wheel. Let's find the instant center I58 using the Kennedy circle. In the Kennedy circle, aside from the triangle 158 that we have already seen, the triangles that share the line I58 are link 568 and link 578. Let's first look at triangle 568. Triangle 568, as shown in the figure on the right, consists of body 5, upper arm 6, and right wheel 8. The instantaneous centers I56 and I68 are joints connecting two adjacent links, so they can be easily found as shown in the figure on the right. According to Kennedy's theorem, the three instant centers shared by these three links, body, upper arm, and right wheel, must all be in a straight line. These three instant centers correspond to the three line segments that form triangle 568 in the Kennedy circle on the upper left. Therefore, the instant center, I58, must be somewhere on the straight line between the instant center, I56, and the instant center, I68. Since we have found one line, we need to find another line, and if we find the point of intersection of these two lines, that point will be the swing center. Let's continue and find another line. If we examine the triangle 578 in the right figure, it consists of body 5, lower arm 7, and right wheel 8. The instantaneous centers I57 and I78 are joints connecting two adjacent links, so they can be easily found, as shown in the right figure. According to Kennedy's theorem, all three instant centers shared by these three links, the body, lower arm, and right wheel, must be on a straight line. These three instant centers correspond to the three line segments that form the triangle 578 in the lower left Kennedy circle. Therefore, the instant center, I58, must be somewhere on the straight line connecting instant center, I57, and instant center, I78. Therefore, the point where the line connecting the instant center, I56, and the instant center, I68, which we found earlier, intersects the line connecting the instant center, I57, and the instant center, I78, which we just found, is the instant center, I58, which satisfies Kennedy's theorem, and is the first swing center that we are looking for. Since we found the first swing center, I58, let's find the instant center, I25, in the same way. Let's look at the triangle 125 of the Kennedy circle. According to Kennedy's theorem, the instantaneous centers of each line segment of the triangle 125 must all be in a straight line. Among the three instant centers, the I12 is a joint connecting link 1 and link 2, so it can be easily found, as shown in the figure. The vehicle lateral cross-section and longitudinal cross-section passing through the left wheel instant center I12 both pass through the center of the left wheel. Let's find the instant center I25 using the Kennedy circle. Kennedy's theorem tells us that the instant centers I15, I18, and I58 must be in a straight line, and also that the instant centers I15, I12, and I25 must be in a straight line. Therefore, if we find the instant center I25, we can find the instant center I15 by using the instant center I58 that we found earlier. In the Kennedy circle, excluding the triangle 125 that we have already looked at, the triangles that share the straight line I25 are link 245 and link 235. Let's look at triangle 245 first. If we look at triangle 245 in the right figure, it consists of left wheel 2, lower arm 4, and body 5. Instant center, I24 and instant center, I45 are joints connecting two adjacent links, so they can be easily found as shown in the right figure. According to Kennedy's theorem, all three instant centers shared by these three links, left wheel, lower arm, and body, must be in a straight line. These three instant centers correspond to the three line segments that form triangle 2 for 5 in the Kennedy circle on the upper left. Therefore, instant center I25 must be somewhere on the straight line connecting instant center I24 and instant center I45. Since we found one straight line, let's find another straight line, and if we find the point of intersection of these two straight lines, this point will be the instant center of the left wheel 2 for the body 5, and also, this point is the second swing center. Let's continue and find another straight line. Let's look at another triangle 2, 3, 5 in the right figure. It consists of left wheel 2, upper arm 3, and body 5. Instant center I23 and instant center I35 are joints connecting two adjacent links, so they can be easily found as shown in the right figure. According to Kennedy's theorem, all three instant centers shared by these three links, left wheel, upper arm, and body, must be in a straight line. These three instant centers correspond to the three line segments that form triangle 2, 3, 5 in the lower left Kennedy circle. Therefore, instant center I25 must be somewhere on the straight line connecting instant center I23 and instant center I35. Therefore, the point where the straight line connecting the instant center I24 and instant center I45 that we found earlier intersects the straight line connecting the instant center I23 and instant center I35 that we just found is the instant center I25 of the left wheel 2 with respect to body 5 that satisfies Kennedy's theorem, and it is the second swing center that we found. Now that we have found the instant center I25, we can use it together with the instant center I58 that we found earlier to find the instant center I15 of body 5 with respect to the road 1. So far, we have found the instant center of the right wheel 8 with respect to body 5 I58 and the instant center of the left wheel 2 with respect to body 5 I25 using the Kennedy's theorem and the Kennedy circle. As mentioned earlier, according to Kennedy's theorem, the instant center of the left triangle I18, I58, and I15 must be in a straight line. Also, the instant center of the right triangle I12, I25, and I15 must also be in a straight line. The point that satisfies both of these conditions is the instant center of the body 5 for the road 1, I15. First, since the three instant centers of the left triangle must be in a straight line in the Kennedy circle, we draw a green line connecting the instant center I18 and the instant center I58. The instant center I15 must be somewhere on this green line according to Kennedy's theorem. Next, the three instant centers of the right triangle in the Kennedy circle must be in a straight line, so draw a red line connecting the instant center I12 and the swing center I25. The instant center I15 must be somewhere on this red line according to Kennedy's theorem. We found the green line for the left triangle of the Kennedy circle earlier. The intersection of these two lines, the green line and the red line, is the instant center I15, which satisfies Kennedy's theorem. As shown in the figure, the instant center I15 is the instant center shared by the road link 1, the right wheel link 8, and the body link 5, and also the instant center shared by the road link 1, the left wheel link 2, and the body link 5. In a suspension with symmetrical left and right sides, the instant center of the body 5 with respect to the road 1 is located on the central vertical line. The instant center I15 found here is the roll center that is conventionally used in vehicle dynamics today. As shown in the figure, the roll center of the suspension, which is symmetrical on the left and right, roll center is located on the central longitudinal plane of the vehicle if the body roll angle is small. For the roll center of the positive double A arm, Since we have thoroughly looked at how to find the roll center using Kennedy's theorem and Kennedy's circle, let's learn how to find it quickly. First, we represent the instant centers I12 and I18 of the left and right wheels with respect to the road surface at the center positions of the tire contact surfaces on both sides, respectively. Next, we represent the straight lines that coincide with the left upper arm and lower arm and find the instant center I25, which is the intersection of these straight lines. This point is the swing center of the left wheel with respect to the body. Next, we represent the straight lines that coincide with the right upper arm and lower arm and find the instant center I58, which is the intersection of these straight lines. This point is the swing center of the right wheel with respect to the body. Finally, we connect the instant center I12 and instant center I25 with straight lines, and we connect the instant center I18 and instant center I58 with straight lines, and we find the instant center I15, which is the intersection of these straight lines. This point is the roll center. For the roll center of the positive double A arm, we have thoroughly looked at how to find the roll center using Kennedy's theorem and Kennedy's circle, so this time we will quickly find the roll center of the negative double A arm. First, we represent the instant centers I12 and I18 of the left and right wheels with respect to the road surface, respectively, at the center positions of the tire contact surfaces on both sides. The lateral cross-sections passing through these two instant centers also pass through the centers of the left and right wheels. In addition, the longitudinal section passing through the instant center I12 of the left wheel passes through the center of the left wheel, and the longitudinal section passing through the instant center of the right wheel also passes through the center of the right wheel. Next, we represent the straight lines that coincide with the left upper arm and lower arm and find the instant center I25, which is the intersection of these straight lines. This point is the swing center of the left wheel with respect to the body. Next, we represent the straight lines that coincide with the right upper arm and lower arm and find the instant center I58, which is the intersection of these straight lines. This point is the swing center of the right wheel with respect to the body. Finally, if you connect instant center I12 and instant center I25 with straight lines and connect instant center I18 and instant center I58 with straight lines and find the intersection of these straight lines, instant center I15, this is the roll center. Just like the positive double A arm, the roll center of the suspension that is symmetrical on both sides is located on the central longitudinal plane of the vehicle. Unlike the positive swing arm suspension, the swing center of the negative swing arm suspension is formed outside the wheel, and the roll center is located under the ground. In the previous video, E0069, Roll Center Part 1, we saw that when sliding on a road surface with a locked wheel, the instantaneous center of the wheel becomes infinite. In the figure on the left, the mechanism of sliding on a road surface with a locked wheel can be expressed as an equivalent mechanism as shown in the figure on the right. The figure on the right shows the mechanism of a rectangular cross-section rod 2 sliding a hollow object 1 with the same rectangular cross-section. In this mechanism, the road is equivalent to link 1 and the sliding wheel is equivalent to link 2. In this way, the instantaneous center of the sliding joint exists at infinity in the direction perpendicular to the sliding direction. Now that we understand the sliding joint, let's find the roll center of the Macpherson suspension. The Macpherson suspension has 8 links and 10 joints, just like the double A-arm suspension. Except for the upper arm of the double A-arm being changed to a strut, all other links are the same. The procedure for finding the roll center of the Macpherson suspension is the same as that of the double A-arm suspension. First, at the center position of the contact surface of both tires on the road, the instant centers of the left and right wheels, I12 and I18, are marked. The lateral cross-section passing through these two instant centers also passes through the centers of the left and right wheels. In addition, the longitudinal section passing through the instant center I12 of the left wheel also passes through the center of the left wheel, and the longitudinal section passing through the instant center I18 of the right wheel also passes through the center of the right wheel. In order to understand the concept of instant center clearly, let's find the instant center based on Kennedy circle and Kennedy theorem, just like in AA arm. The final instant center we want to find is the instant center I15 of the body with respect to the road. In order to find the instant center I15, we must first find the instant center I25 and the instant center I58. First, let's find the instant center I25. The instant center I25 can be found using triangle 2 for 5 in the upper left figure of the Kennedy circle and triangle 2, 3, 5 in the lower left figure. In the upper figure of the Kennedy circle, the instant center I25 must be on a straight line with the instant center I24 and the instant center I45. Since I24 and I45 are the two joints of the left lower arm, we can find them right away. Therefore, we draw a straight line connecting the instant center I24 and I45. The instant center I25 is somewhere on this straight line. Next, in the lower left diagram of the Kennedy circle, the instant center I25 must be on a straight line with the instant center I23 and the instant center I35. Since the left wheel link 2 and the strut link 3 are sliding structures with respect to each other, as we have seen earlier, the instant center I23 is at an infinite distance perpendicular to the strut link. Therefore, we draw a straight line perpendicular to the strut and mark the instant center I23 as infinity. This drawn straight line intersects the line connecting the instant center I24 and the instant center I45 obtained earlier, and the intersection point of these two straight lines is the instant center I25, which is the swing center of the left wheel with respect to the body. As shown in the Kennedy circle and the left figure, the three instant centers I24, I45, and I25, corresponding to the green triangle of the upper left Kennedy circle, are all on a straight line, and the instant centers I35, I25, and I23, corresponding to the green triangle of the lower left Kennedy circle, are also all on a straight line. Here we can find the instant center I58 in the same way we have seen above. The instant center I58 can be found in the upper left diagram of the Kennedy circle using triangle 568 and in the lower left diagram using triangle 578. In the upper left diagram of the Kennedy circle, the instant center I58 must be in a straight line with both the instant center I68 and the instant center I56. Since the right wheel link 8 and the strut link 6 are sliding structures with each other, as we have seen above, the instant center I68 is at an infinite distance perpendicular to the strut link. Therefore, we draw a straight line perpendicular to the strut and mark the instant center I68 as infinity. Next, in the lower left drawing of the Kennedy circle, the instant center I58 should be on a straight line with the instant center I78 and the instant center I57. I78 and I57 are the two joints on the right lower arm, so they can be found right away. Therefore, a straight line is drawn connecting the instant center I78 and I57. The instant center I58 is somewhere on this straight line. This straight line intersects the straight line drawn perpendicular to the strut link 6 from the instant center I56 that we found earlier, and the intersection of these two straight lines is the instant center I58, which is also the swing center of the right wheel with respect to body 5. As shown in the Kennedy circle and the left picture, the three instant centers I56, I58, and I68, corresponding to the green triangle of the upper left Kennedy circle, are all on a straight line, and the instant centers I78, I57, and I58, corresponding to the green triangle of the lower left Kennedy circle, are also all on a straight line. Now that we have the instant center I25 of the left wheel for body 5 and the instant center I58 of the right wheel for body 5, we can use these two to find the instant center I15 of body 5 with respect to road 1. Referring to the upper left Kennedy circle, the three instant centers I15, I58, and I18 that make up triangle 158 must all lie on a straight line. Furthermore, the three instant centers I15, I25, and I12 that make up triangle 152 must all lie on a straight line. In order to satisfy the above two conditions, the instant center I15 must exist at the intersection of the straight lines connecting instant centers I58 and I18 and the straight lines connecting instant centers I12 and I25. In this way, the three instant centers I58, I15, and I18 that form the left triangle in Kennedy circle will all be in a straight line, and also the three instant centers I12, I15, and I25 that form the right triangle 152 will all be in a straight line. As with the double A-arm suspension above, the roll center of the Macpherson suspension, which has relatively little body roll and is symmetrical left and right, is located above the vehicle's central longitudinal section. For the Macpherson suspension, we have sufficiently looked at how to find the roll center using Kennedy's theorem and Kennedy circles, so now let's look at a quick way to find it. First, represent the instant centers I12 and I18 of the left and right wheels with respect to the road, respectively, at the center positions of the contact areas of the two tires. Next, represent the straight line perpendicular to the strut from the body mounting point of the left strut and the straight line coincident with the lower arm, and find the instant center I25, which is the intersection of these straight lines. This is the swing center of the left wheel with respect to the body. Next, represent the straight line perpendicular to the strut from the body mounting point of the right strut and the straight line coincident with the lower arm, and find the instant center I58, which is the intersection of these straight lines. This is the swing center of the right wheel with respect to the body. Finally, connect instant center I12 and instant center I25 with straight lines, and connect instant center I18 and instant center I58 with straight lines, and find the intersection of these straight lines, instant center I15. This is the roll center. If the body roll angle is relatively small, and the left and right suspension are symmetrical, the roll center is located on the center longitudinal plane of the vehicle. Let's find the answer to the quiz. In what case is the kinematic roll center located in the central longitudinal plane of the vehicle? In an asymmetric suspension, the kinematic roll center is not located in the central longitudinal plane of the vehicle. When a relatively large lateral force is applied in a symmetric suspension, the installation angles of the suspension links change, so the kinematic roll center is not located in the central longitudinal plane of the vehicle. When the suspension is symmetrical and a relatively small lateral force is applied, so the body roll angle is small, the kinematic roll center is located in the central longitudinal plane of the vehicle, so number 3 is the correct answer. When the deformations of the suspension bushes are large, the installation angles of the suspension links change, so the kinematic roll center is not located in the central longitudinal plane of the vehicle. Let's summarize. The assumptions for finding the kinematic roll center are as follows. The distance between the left and right tires is constant. The tires are assumed to be fixed to the road with rotatable pins. The deformations of the suspension bushes and tire is ignored. The lateral acceleration must be small enough that there is little change in the suspension. The swing center is the instantaneous center of the wheel relative to the body. There are two types of suspension geometry. In a positive swing arm geometry, the swing center is formed inside the vehicle and the roll center is located above the ground. In a negative swing arm geometry, the swing center is formed outside the vehicle and the roll center is located below the ground. Steps to find the instant center can be summarized as follows. Use the Kennedy circle to find the two swing centers for the left and right wheels. In the Macpherson strut, the instant center of the wheel relative to the strut exists at infinity in the direction perpendicular to the strut. Denote two straight lines connecting the left and right wheels, the road contact points, and the swing centers of the corresponding wheels. The point where these two lines intersect is the instant center of the body relative to the road, and this point is the roll center. The conditions for the roll center to be located on the vehicle's central longitudinal plane are as follows. The suspension must be symmetrical on both sides. The lateral acceleration must be sufficiently small to ignore the body roll angle. The deformation of the suspension bush must be small. The deformation of the tire must be small. Summarizing the last three conditions, we can say that the change in the installation angle of each suspension link must be negligible. If you watch the previous videos, you can learn about various fields of automotive knowledge and enjoy a more in-depth understanding of future videos. In the last video, E0068, the fourth part of curve fitting using the least square method, I explained a method for more accurate curve fitting by assigning importance to data using a weight function in the least squares method. In my recent video, H0069, I explained the theory of kinematics as the first part of vehicle roll center and how to find the instant center using the Aaron-Holt-Kennedy theorem. The following video will explain how to find the roll center of a vehicle roll center part 3, a trailing arm suspension and a solid axle suspension. Please hit the thumbs up and catch the brand new videos by free subscription. So what are you waiting for? See you at next videos. Goodbye guys.